In this video, we are going to learn about how to convert the given PDA into a context-free grammar. So for that, we can see a simple example now. So what is the meaning of this PDA? Here it is given some tuples, that is PDA, Pn is defined as it will be having a single state, that is Q, with input symbols 0, 1, stack symbols z, a, b, with some set of transition functions that is given over here, and initial state is Q, final state is z. Okay, so you are this much initial state is Q, and the initial stack symbol will be z. So this one is the final state. Okay, what is the tuples? That is Q, sigma, gamma, del, Q0, that is the initial state, and Z is the stack symbol, initial stack symbol, that is Z0. Okay, so here it is not given, the final state is not being mentioned, which means that it will, the given PDA, it is accepting the strings by emptying the stack. Okay, so the given PDA, it is accepting the strings by emptying the stack. Why? Here in the tuples, the final state is not being mentioned, only the initial state as well as the initial stack symbol only it is mentioned in the given PDA. Also some transition functions are there. Okay, so first you need to understand the transition function so that you will be able to convert it into the context-free grammar. So the stack symbols as given over here is Z, A and B. Input symbols is 0 and 1. So grammar, it will be like it is variables, terminals, productions and the start symbol. So the start symbol, I am taking it as A for the grammar that we have to generate for this PDA. So let the start symbol be S. Okay, so here when a PDA is given and when you are asked to convert the given PDA to a grammar, what you have to know is the variables, that is here V is there, no? Variables will be having some form like this, it will be having. Okay, so the variables are similar to S, only the start symbol we will be specifying like this, S. The other set of variables, it will be denoted like this, that is P, X, Q, where P and Q, they are the states in capital Q. Okay, so Q, you know that you know that from the PDA itself, and if here in our example we are having only a single state, that is Q. So the variables for this corresponding PDA will be denoted like this, that is PXQ, where X will be some stack symbol, X will be an element of stack symbol, and P and Q will be the element of Q. So this thing you need to keep in mind. The variables that we are designing for the grammar that is going to be generated from the PDA will be like in this format. Okay, PXQ, where P and Q are the states in Q and X is the stack symbol in gamma. Okay, now the productions, we can start with the productions. So as I have said, the start symbol will be S itself. Okay, any letter you can take as a start symbol. And what does that start symbol gives? So here, since there is a single state Q, okay, it will be taking some format that is given in the square bracket. So for the start symbol, initial state will be coming as the first state and the final state will be coming as the second. That is, if the variable is PXQ, then here it will be coming the initial state Q, and this Q will be the next state. If there is more than one state, and if you are having Q0, Q1, Q2, like that, if you are having, means you need to write the productions for all these states, citing that x gives q0 if the stack symbol is z0, initial stack symbol is z0, and the next state will be q0 z0 q1. S gives q0 z0 q2. Okay, then one more is there, that is S gives q0 z0 q0. Okay, for all these states you have to write the start symbol cases. So for time being, in our example, we are having only a single state. So you can write the production as, what is the name of the state? Q. And what is the initial stack symbol that we have to place over in the middle? That is Z. Z is the initial stack symbol. So Q is Z, and the target state, only one state is there. So Q is Z Q. So this will be the first production for the start symbol S. Okay, now you have to consider what each and every functions you have to consider. So first you can consider the function del of q comma 0 comma z, which is equal to q comma az. So what does that function indicates? When it reads the input symbol 0, and if the top stack symbol is z, then you have to push the element a into the stack. So this can be written as a format is there, that is, as you all know, our variables will be enclosed within the square bracket. So square bracket gives here, since there is two stack symbols are mentioned over here, then here also you will be having two elements that is enclosed, two variables that is enclosed within the square bracket. Okay, now what is each the square bracket content will be taking the same format that we have learned in the previous production. Okay, so how you have to enter the elements that we are going to see next. So here, since here only a single state is there, so you can just write it like here it becomes Q. This A comes in the middle, that is capital A, and this comes in the middle of this second variable is Z. Okay, so since here only a single we are considering only a single state case. Okay, here since only a single state is there, that state will be mentioned over here. What is the state that is given? That will be mentioned over here. Then A, that is a stack symbol will be given in the middle of that variable, inside that square bracket. Then Z will be second variable, second stack symbol will be given in the middle of the second variable that is given inside the square bracket. Okay, now in the left hand side of this arrow, what you have to write here, you will be having this state will be written here, Q. Then this stack symbol comes in the middle, is Z, Q is Z. And here only a single state is there, no? So you can make it as take Q. You can take it as Q itself. So the left hand symbol variable will be like Q is Z Q. Okay, Q is Z Q, and the right hand side will be written like this, Q A. This, since there is only a single state, you can place Q over here. Okay, again here Q. Actually, if there is more than one state, means based on the number of states you will be, that is the different states. If Q0 means the same thing will be written here. Okay, that we can see it in the next example. For time being, write Q in both the sides. And here what is written, that is this, what is written over here will be written here also. Which means these two things will be the same and these two states will be the same state. That is the thing you need to keep in mind. And this you can see, since here only only a single state is used, that difference you won't be able to understand now. When we use more than one state, you will be able to understand that difference. Okay, for time being, you are using the same name of the state as Q itself, which means a single state. Now one more thing is there, that is this operation will be done only if it reads the input 0 from the input table. So when in order to write that into a context free grammar, this 0 comes here. That is, the right hand side starts with a 0. The right hand side, it will be starting with a 0. Okay. So the given production or the obtained production is, this one is obtained production, which means Q is that Q gives 0, Q A Q and Q is at Q. So this will be the second production. So first production is for the start symbol S, Q is at Q. And second production is for Q is at Q, you will be using the right hand side as 0, QAQ and Q is at Q. So how you got this production? This state, the variables will be represented using this representation. That is, it will be enclosed within the square bracket, in which the middle element will be the stack variable that is given over here. And the left and right will be the state names. And what is the input that is being read? It will be given, the right hand side will be starting with that input variable, input terminal or input symbol, and following that it will be having AZ, isn't it? In the transition function it is given as AZ. Two variables are there. So two stack symbols are given in the right hand side. So the grammar also need to have two variables in the right hand side, which represents the non-terminals, and those stack symbols will be occupying the middle position. Left and right will be having the state names. Okay, so we can once more see the same thing with the help. We can try to implement the second function. So how it can be written? Second function, that is del of Q comma 1 comma Z will be equal to Q comma BZ. So the grammar can be written as how? The inside square, since there is two variables over here, the grammar can be written in the form of square bracket. Two square brackets will be there because in stack symbols here it is given as two stack symbols, isn't it? B and Z. Now this stack symbol comes in the middle of the left hand side. Left and right will be taking the state names. So the left hand side is like this. Then the right hand side will be, since here the input read is 1, this 1 will be written over here. Okay, and then here also this B will be coming in the middle, B. Z will be coming here, Z. Now state names Q. Okay, so what does this mean? This is a non-terminal Q is at Q, which gives 1 Q B Q and Q is at Q. Okay. Okay, this is a case, only one production is generated because we are in the set of functions that is given here, only one state is there. Okay, if there are more than one state, if there are two states, means for single function you will be able, you have to generate more than one productions. Okay, that we can see in the next example. So for time being, learn how to formulate this variable names and how a production can be written from this transition function. Okay, so we can, so this one also we have written. So for this function, the production in the grammar can be written like this. Okay, now we can see this production, the third function, that is del of q comma 0 comma a is equal to q comma AA. Here also what happens, in the right hand side, two non-terminals are there. Oh, sorry, stack symbols are there. Two stack symbols are there, which means that our right hand side, that is the production right hand side also, it needs to have that two non-terminals. Okay, stack symbols equivalent to the stack symbols, you need to have the two non-terminals in the right hand side, and here a single non-terminal will be there, and non-terminals will be represented using the square bracket. So now you have to name those non-terminals. So what is the name of the left hand side non-terminal? You need to keep this A in the middle, name the states, give the states Q, left and right. Now here, since the input red is 0, right hand side will be starting with the terminal 0. Now again followed with two non-terminals. So what will be the non-terminal? Middle will be taking the stack symbols. So here both the stack symbols, they are A. So here all in our production also, the middle will be symbol will be taking the A, will be taking the symbol, that is a variable A. Now in order to make it as a non-terminal, the format is you have to include the state name, and left and right you are including the state as Q for both the cases. So this will be the production that is generated for that function. Okay, similar is the case with this function del. Okay, del of q comma 1 comma b, which is equal to q comma bb. What will be the production? Del okay, what will be the production? Here also you are having two stack symbols. So in our production also you need to have two non-terminals. Then here left hand side, since the stack symbol is B, middle you have to write B, state QQ, and here's the input red is 1, so place right hand side should start with 1, and BB. In the right hand side, the stack is having, you are pushing the element B onto the stack, isn't it? So the stack symbols used in the right hand side is BB. So here non-terminals also you will be having B in the middle, and the state will be included. Okay, so this will be the production corresponding to this function. Okay, so this is the method that is being applied to generate the production if the number of states that is given in the PDA is 1. Okay, only one state is given, means you have to apply this rule. Also provided if the right hand side, if it is making use of two non-terminals, then two stack symbols, then the production also need to have two non-terminals in the right hand side. If there is a single non-terminal, means we need to have only a single if there is only a single stack symbol is there in the right hand side, means you need to have only a single non-terminal in the right hand side for the grammar also. Okay, that example also we can see later. Now here one more thing what you need to see is, if there is no stack symbols, which means epsilon is there. The meaning conveyed there is we are popping the element from the stack, which means there is no stack symbols for that function. So in such case, what you have to do is, so you can take an example, del of q comma 0 comma b is equal to q comma epsilon. So this is a function we are considering. Okay, so as said earlier, what you have here, there is no stack symbol, so the right hand side of the grammar also will not be having any non-terminals. Based on the stack symbols that is given in the right hand side of the PDA function, we will be determining the non-terminals that is present in the right hand side. So what will be the grammar for what will be the production that is generated for this function? This stack symbol, it comes in the middle of the non-terminal, that is we are going to design, that is B. Left and right you can specify the state name QQ, and right hand side input read is 0, so it starts with 0. Whether any non-terminals will be there in the right hand side? No, because the stack symbol used over here is epsilon, so there won't be any non-terminals for this production. Okay, so this will be the grammar, this will be the production for this particular function. Similarly, you can try for this also, that is del of q comma 1 comma a, which is equal to q comma epsilon. How you will be able to write? Here right hand side there is no stack symbol, so in our grammar also the right hand side will not be having any non-terminals. Here left hand side you need to generate you need to give a non-terminal with the middle element as a, put the state in left and right, and 1 is the input that is being read, so the right hand side will be having 1. So the production that is generated will be QAQ gives 1. Okay, now we can see the last function that is defined over here. Q epsilon is z is equal to q comma epsilon. So how you can write? You need to place this z in the middle, so z, q will be placed in the left and right. Right hand side no stack symbols are there, so no non-terminals, and input read is epsilon, so here it becomes right hand side it will be epsilon and with no non-terminals. So the production that is generated for this particular function will be q is at q. Okay, so individually you will be able to write the functions for the specific write the productions for the specific functions that is given in the PDA. Okay, so what all are the productions? That is using this arrow you have generated some productions, isn't it, for each functions. Those productions you need to combine it together, and you have to specify that the complete grammar, for the given PDA will be is Nornetta. You have to write what the set of productions, that is S gives Q is at Q. So what you have to keep in mind is the non-terminals should be enclosed within the square bracket. Only the start symbol S that we have specified here is not enclosed in the square bracket. The other things that we have inserted as new non-terminals will be enclosed in the square bracket. Q is at Q, and Q is at Q gives 0, Q is at Q, QAQ, 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 QAQ, QZQ. Then QZQ gives 1, QBQ, QZQ. Then QAQ, 0, QAQ, QAQ. QBQ, 1, QBQ, QBQ. Then QBQ, 0, QAQ, 1, QZQ, epsilon. So this will be the set of productions for the generated grammar. Okay, so which all are the non-terminals here? So you can write the tuples also. The subtuples will be like non-terminals. V will be the set S, QZQ, then QAQ, QBQ. These are the non-terminals. And terminals will be, T will be 0 and 1. Okay, so productions it is being listed and start symbol is yes. Okay, so if you want you can rename also. These states you can rename as any single non-terminal like this can be written as A. QZQ can be renamed as A, and QAQ can be renamed as B. QBQ can be renamed as C. And in place of these QAQ, you can replace it with B. Okay, that is optional one. Now you can just try by yourself and see whether you are able to write the same. You are able to generate the same productions for the given PDA. Now in next example will be like here only a single state is used, isn't it? Now next example will be like one or more than one states will be there, and how then in such cases how you will be able to generate the function for the also generate the productions for the given PDA.